So one of the things that we'd like to do as part of this workshop is to emphasize the point that this is not just science but also engineering. And one step we're taking on that is to invite Bill Rouse to be our next speaker. He is the executive director of the Tenenbaum Institute for Enterprise Transformation at Georgia Tech. He's broadly experienced in systems engineering, organizational performance, information systems, and many, many related areas. It's a long sentence. One of his current passions is attacking the national healthcare challenge with his arsenal of systems engineering tools. And I think he's the only person I know who stands a hope of making a dent in this. I first got to know him on the Air Force Science Advisory Board, where his real-world experience was a healthy antidote to a bunch of academics and fighter pilots. So that's his role today. Bill?
I hope the color looks better to you than me. Can everybody read them? Okay. Well, I first got involved with this issue doing some work with the executive team at IEEE. And there, as you can imagine, are immersed in smart grid and the standards associated with this. And one of the team members said, you know, this is going to be really difficult if consumers choose to ignore it. If consumers don't really even pay attention to the fact that there's dynamic pricing and various sensing available. And they wondered what would it take to enable and motivate consumers to engage in smart grid. At the same time, and I'll put their names up there now so you can see them, at the same time several students came to me and they were very excited about this whole smart grid thing. And all of them are between probably ages of 22 and 26 or so. They're all graduate students. And as you'll see when I get to some of the research topics they suggested, they conceptualize this a bit different than I would have inherently. For example, having social networks in different neighborhoods compete to see who could be the best at managing their energy consumption and things like this. They immediately saw how some of the ways you could connect these ideas to Facebook and other things, which wouldn't be where I started on this. But so a lot of the thinking here came from this set of students, and we spent a whole summer immersed in this. So all of you know about smart grid and its progress and investments in infrastructure, and so there's a, if you will, a smart grid juggernaut coming down the pike. The question is, how do you get consumers to be engaged? Now, actually, Bob mentioned our work in healthcare. We're facing the exact same issue there, and it's a fairly good analogy. We've done analysis to show that the only way you could actually get healthcare costs to track GDP is if you can get the cost of labor out of the system. Well, how do you get the cost of labor out of the system? Well, one of the best ways, I think, is to enable and motivate people to manage their own health. And that's another whole talk. Okay? But this is the same thing here, is how do we get the consumers engaged and wanting to do this? It may seem sort of obvious, well, why wouldn't everybody like this, right? But there have been pushback in California, Maryland. Some of the issues related to privacy. For example, I've seen some data which is really rather amazing that smart meters, you can take the trace from a smart meter and you can see what appliances people have, when they turn them on, when they turn them off. You can make pretty good inferences about whether they're in their home at the moment and other things. It's really pretty straightforward to do that. I was surprised. You also can see that their GE refrigerator is near the end of its useful life, and this would be a good time to contact them to sell them a new refrigerator. Okay, so there's some pushback about whether or not the people want their utilities to know that much about them. And there's some general survey results that show that consumers in general don't trust their utilities. They don't think that service to them is their first priority. So how do we get consumers engaged? One is obviously education, awareness, et cetera, but a lot of what we're going to talk about later is what kind of tools would people need to do this. As you probably know, there are an enormous number of companies in this space right now who have various ideas, and I'll come to those companies later. But how do we create the right incentives? Now, it's pretty clear that we could get consumers to act, and we'll talk about dynamic pricing in a few minutes. If the cost of your electricity between, say, 5 p.m. and 10 p.m. was 10 times the price during the rest of the day, you probably wouldn't wash your clothes in the evening. Okay? However, we run into the other problem. What about the significant percentage of the population that wouldn't understand that? How do we deal with that, the sort of social equity issue, too? So what are the primary consumer benefits? The idea you could reduce energy consumption, or you could reduce energy cost by managing when you consume energy. People will need tools to do that, but there have been pilot programs, and I'll talk about some data later on. People will respond. You can create conditions under which people will respond. One little thing I'll come back to again later, this utility bill that you get every 30 days, and you say, gee, it was $240 last month, it's very hard for you, any of us, as trained as we are, to infer what we did to cause that $240 bill. Okay? And some of the results later on show that if we actually knew by the hour what we were consuming, people will react and turn devices off, et cetera. The other consumer benefits, and this really came from the students, they felt they would have enhanced social status as being good stewards of energy, and that they would be a social force among them and their peers. And this was 100% consensus among the students that this was true. Reduced environmental impact, et cetera. So there are a variety of benefits. There are consumer cost comparison. So the rates in Georgia just went up substantially because they got the right to build a nuclear power plant sometime in the future. They could increase the rates now to start accumulating funds for that. That increased costs to the consumer will persist whether or not they build the plant or not. Okay, so everything is linked to capital expenditures. If we could use the right kind of methods and tools so consumers could manage their energy and consume more energy off-peak, we would build fewer power plants. Now, on the other hand, if your whole rate base is determined by the number of power plants you build, there's a little bit of a conflict there in terms of the incentive system. The utilities have various benefits and costs. Although it seems to me, and as we look at some of the companies in a few minutes, it's not clear the utilities will be the innovators in this space. There's a lot of other companies that are looking for how they can support and enable the consumer. But there is a case to be made. There are the kind of incentives the consumer has. The studies show that if you could save between $15 and $50 a month on your utility bill, people will act. They are much less likely to act if the benefit is primary to the utility. The utilities have some incentives about peak and long-term demand. I saw some data about this. I think 5% of the capacity in the United States is used like 8 hours a year. What we need is an integrated approach, so both consumers and utilities want to play the game, that everybody wins. And we want to maximize consumer engagement. We found the similar thing in health, the extent to which we can maximize consumer engagement, patient engagement. A lot of things can be improved. In the end, the market mechanisms do work if you design them right and they evolve correctly. So what's the system concept here? This is one way of looking at smart grid. We have the consumers, the utilities, the regulatory agencies, the third-party companies. I'm not going to bother to talk through every element here, but you can see there's incentives, lobbying, marketing, pricing, et cetera. There's all sorts of things going on in this grid. Now, one of the things is that seems to have the enormous importance from the studies I've seen is the latency and resolution of the information that the consumer gets. And so if we look at this here, right now we get information, it's 30 days old, we get it once a month, you read the bill, we have no idea what to do with that other than pay it. But there have been numerous studies that show if we can, not necessarily instantaneously, but get information much more quickly, consumers will respond and they will change their habits. Smart meters could enable that. Right now, the only entity getting the smart meters readings is the utility, not the consumer. And then we have different ways that this can work with different kinds of devices. Your smartphone, your equivalent of a set-top box, your computer, and over in the far right there we have your paper bill. And as I said, there are an enormous number of companies in this. One of the things that the students did an amazing job on was researching every company they could find that was involved in this, what they're doing, what their potential competitive advantage was, what technologies they're relying on, and trying to predict from that what standards would likely emerge in the eventual system. So one of the whole issue is how is the human going to interact with this system? It seems inevitable that it's going to be something like bill pay. Bill pay is a huge success. I would imagine most people here use it, and you pay your bills online. You almost forget what a stamp is. And what you're basically able to do is you're able to manage the float to your advantage. You pay things when you want to pay them. You are in control of it. And so that's been a metaphor for this. And now bill pay is a lot simpler than the problem we have here. The kinds of interfaces are obviously paper we currently have. It could be web-based, it could be an in-home box. In our interactions with Cisco, they really want there to be an in-home box that you have to buy. As I mentioned in our discussions at dinner last night, the senior vice president said to me, really all I want to get is $10 a month from every person in the United States every month. Yeah. That's a significant amount of money. And then we want to take our iPhone or our Droid or whatever we're using and be able to control things remotely. So we want to actually be able to use all these different ways of interacting. We probably don't want the paper, but. And there are all these people, this is just representative people in the game that are involved. And there's many more than this. There's an enormous list of companies involved. So how do we provide this electricity usage information? We want to provide it through a variety of means. There actually are home automation systems available now that enable rather sophisticated control of your energy consumption. They're rather expensive and they're require someone that's sort of committed to learning how to use something like that, but it is available now. The advanced metering infrastructure can measure energy usage at time. It's interesting if we can see from your trace of your smart meter that your refrigerator is really a problem. If we then try to sell you a refrigerator, consumers found that objectionable. If we just tell you that your refrigerator is a problem, people kind of like to know that. So it depends on how the information get used. The last bullet here, the students really were into this notion of being able to create neighborhoods and social groups that would excel and compete with each other in terms of their ability to not only share energy, but share best practices about how they figure out how to do things. We found this in some of our stuff in health, too. I'm wondering in the future when people have a health problem that the first outlet for getting information on a health problem is going to be their Facebook friends rather than the health system. So there's some requirements here. The information richness, it can be much richer than we think about it right now. It needs to be secure. You don't want to have your house disrupted. Privacy is an enormous issue, much more so than I thought about when we got into this. We also want it simple, and we want to have a sense of being in control of what's going on. There's lots of interface. We have loads of things to draw upon from computing, interactive computing, human-centered computing, et cetera, to help do this. So I think the component technologies are often there. The question is whether we can put them together in a compelling way at a reasonable cost. I mean, I think we've seen, like with the iPhone, that that's possible. And actually, interestingly, like the iPhone is a good example. People are actually have demonstrated their willingness to pay much bigger telecom bills than they used to. Now they're getting a lot more features and functions than they used to. But okay, are people really sensitive to the pricing? Will they really react? The idea of making energy 10 times more expensive in the evening, that's not going to happen. It's not going to be that extreme. Okay? But these are the different models currently being considered. Critical peak pricing is the common one. There are things looking at real-time dynamic pricing where the pricing changes by the minute. I think that might be a little difficult for the consumer to keep up with. That would affect more industry where people actually could spend dedicated personnel on that. But there's just an enormous number of these things that people are considering. And I think critical peak pricing is the one that comes up most often. There's been a variety of studies with real-time pricing, and these elasticities, the fact that they're negative, shows that people will reduce their energy consumption if you vary the price. They'll react to it. And time of use pricing, similar. So there is, you can influence their behavior. Now, if you had those sensitivities, these are the kind of models you could plug them into that would allow you to look at energy consumption as a function of elasticity and a bunch of other parameters. So we have the equations, the models to plug this kind of stuff into, more of the same. So the state of our knowledge is pretty good there. The question is what's going to actually create a greater elasticity than other things. Recent studies. A summary of 15 recent empirical studies is that the dynamic pricing affects usage depending on the magnitude of the price increase. That's not very surprising. If it's big, it'll have an impact. Whether or not people have central air conditioning has an enormous impact on whether they respond to dynamic pricing. And then are there enabling technologies? For example, are there two-way programmable communicating thermostats so you can remotely change your level of your temperature? And you can see the responses here. On the one hand, 3% to 44% that would enable people a drop in demand during peak periods. So it can work. Now, I'm going to summarize some conundrums and then talk about 3 research avenues. One conundrum is who pays. The utility actually wants you to pay for any kind of device or anything that's needed to do this. In other words, they don't want to invest in that for you. Another is why change. The utility is a massively long-regulated industry, and the idea of doing something innovative like this doesn't really fit in. There's a question of who wins, who actually gains because of this. Does the utility gain? Do you gain? I think the consumer has to gain something for this to work. Another thing with consumers is why play? Why even bother to get involved? Is it going to make a big difference? If dynamic pricing means my utility bill goes up $5 a month, I'm going to probably ignore it. When is it safe relative to security? A major issue is who knows what's going on in my house? And then finally, the question of where do we store energy to deal with peak demand, which is a little bit of a different issue. Now, this is what the team came up with. If they were going to do research now to try to enable and motivate the consumer, what would they do research on? One thing is developing market simulations. The notion being that you could take some simulations, probably agent-based modeling and some other representations, and you could do what if and try different things and make different assumptions and find out where really are the breakpoints, and then maybe go empirically validate those in the market. It's interesting, as part of this class, we had a candidate for the utility commission come. It was before the elections, and come and talk to the class. It was a very interesting experience. He was the first engineer to ever run for the Public Utility Commission. He lost to a pickle salesman and an undertaker. But we talked about, this commission basically sets the rates. And we asked him, well, how do you know the impact of the rates on how the system will perform? he says, well, basically, the utility comes in with a rate proposal. The consumers come in and protest. We have a meeting, and we find some place in the middle that they walk out of the meeting, and that's it. I said, well, but how do you know the consequences of your decisions? He said, we're just making a judgment. Okay, so it's very, very little analytics involved with doing this, but a market simulation would allow something like that. Also, the whole question of developing model of consumers, some kinds of ways of having a much deeper understanding of how people make their choices and what influences their choices. But the winner, and the students are actually working on this now, is the whole idea of creating games, creating an online game. The online game that they are building is, in the game you have an avatar, and the avatar is your house. And actually, they're building it in Caneva, one of the game platforms, and it's your house literally. Geometrically, it's your house. It's your exact appliances. It's everything that's in your house. And you're learning how to manage the energy consumption of that avatar house. And I mentioned Cisco before. What they would like to do is once you figure out what you want your house to run like, they want you to download it into the Cisco box, and it'll then run your house, and they get the $10 a month for that. That's their model. The students are cool about that except for the $10. The interesting thing that they came up with is they wanted there to be a token economy, so you earn some kind of credits for being good at this. Besides anything you save in your utility bill, you earn some kind of credits that you could use in a variety of ways. One is you could buy things in this virtual environment like you do in Second Life and in Caneva. The other is you could donate them. One of the ideas was that you earn carbon credits by managing your energy better, and then you can donate those carbon credits to some organization or some philanthropic organization or social organization that you want. And so this idea, it's hard to keep the students off of it, even if their research is in another area. They're pretty excited about this, and I think we'll proceed. The interesting thing about it is when you look at what they're talking about and you think about older folks, it's really hard to imagine them doing it. On the other hand, the younger folks are just so into this, and they're just so, they're digital natives. Most of us here are digital immigrants, right? And they're digital natives, and this just seems so natural way to think about this in terms of thinking of it as a social issue, not just a technical energy management issue. So basically, the bottom line here is that enabling and motivating the consumers to manage their own energy. The experiments we've seen, the data we've seen, it is possible to get people to change their behaviors. They will not inherently do that. Part of it is related to the information they get and when they get it. Part of it is related to the incentives that they have. And within those incentives can be the whole issue of the social networking among peers who are also trying to do this. So I think it's a pretty exciting possibility. I can easily envision that you go to your desktop or laptop just the way you go to do bill pay now, and you go in and you look at your energy management scheme, and you look at how it's performing, you twiddle with it a bit, take the idea that your neighbor sent you, maybe put in that algorithm, what if I just looked at the slope rather than the magnitude, whatever, I don't know. And that this could work and could make a huge difference in terms of the sustainability of the energy system. Thank you.
So it was a very interesting talk in terms of the motivations for the workshop. To me, it highlighted the importance of looking at IT and the social sciences and that intersection, social equity and privacy concerns, integrated approaches. And this was the most striking to me because I hear this over and over again, the importance of being on the ground, the fact that the smart grid could be foiled by concerns with privacy is a surprise to me too. But at the CSTB workshop, during a public meeting, we had a speaker talk about attribute importance of privacy. And it's not as important to everybody. It varies with people in the population. It varies across countries. Do you see possibilities for customization? I mean, that's one of the big promises of IT, that we can customize to particular users. And when you're talking about consumer modeling, can we take the results of that modeling and allow some people to buy into these things in which there are privacy concerns, but they're not terribly concerned with them, and in other cases we allow them to buy out?
Well, I think this is a really good point. My sense is, especially among the younger people, where they seem to be willing to share an amazing amount of information about themselves, but they like that they actually get to decide to do that, rather than as the information is just taken. So I think if the consumer feels in control, then some people will opt in to be really sharing information and best practices, and some people just are not going to want to do that, and that will just be the way it is. I agree with you that we need to be able to customize that aspect of it to the consumer's preferences so they don't feel reluctant to participate.
Hi, I'm Maria Ilic from CMU. I am trying to think about, I work in smart grids. We actually have a center now at Carnegie Mellon in the SRC sponsor center on smart grids, and the picture that you painted was primarily from the customer side, but I think there is a lot of open questions on how to integrate those new methods and new activities on the customer side into the legacy power system. And unless we look at the whole thing as a system, for example, right now utilities are using traditional top-down OR methods for scheduling, and they don't come together with decision-making by the agents from bottom up. And I think you take any textbook in power systems, it doesn't even lend itself to including the customer from the utility side. So I would just suggest that there is a lot of work to rethink the overall model of the interactive, IT and the information exchange of the entire supply chain from the customers all the way to the utilities and back. Because if we don't do that, the signal to the customers is never going to be good enough. Utilities will not pay back for not building another power plant, etc. They usually maybe just the price on the spot in real time, which is maybe less than 10% of what customers should be getting back. So just the whole methodology of rethinking the model, which includes decision-making at the end-user side and distributed generation, et cetera, I think it's a completely open area. If you could comment on that.
I agree with you. As I mentioned real early on, it's not clear to me that the utilities are going to be the innovators here. There's a lot of other people that are much more consumer and market oriented that know that they have to provide clear value for the consumer to buy in. These players are people who are not used to having a monopolistic position in a market, so they behave differently, they decide differently. So I agree with the
so
statement.
So the question is how to evolve, what type of research you do to actually evolve these two completely different, things. There is a huge gap there, and I would strongly encourage us to think about that in terms of the methods used, and the sort of leadership on the NSF side.
One mechanism, I don't know how each state operates, but within Georgia, the Public Service Commission, they could be much more sophisticated, which would force the utilities to be much more sophisticated, and the consumer groups too, in terms of how they think about this more broadly. That would help.
Herb Simon, who was a Nobel laureate in economics as well as a computer scientist, once said that a hidden currency is human attention. So I don't know to what degree your models explicitly include it, but I think that your students certainly got the intuition right. The reason for the games is that causes the humans to spend their attention in order to optimize a particular function, in this case competing with their neighboring social groups. So to relate that to the what I think would be a logical next step to what you're doing, or maybe you're already doing it, if you can get dynamic information, for example, when wind power or solar becomes a much larger fraction of the total production, and a lot of the energy will go to waste. The turbines are generating it, but we don't have sufficient storage capacity to keep it, and then that would be a time in which it could be priced very low. It could be priced for the cost of transmission, essentially. If that dynamic information was coming, but it did not require human attention, minute to minute or hour to hour, but instead it was done by local software or cloud available software to optimize, I think you can probably get a lot more action For example, they can put the wash in and says, do it sometime in the next 24 hours, or charge the car sometime in the next 24 hours, or whatever it is that it can be variable consumption. If it can be left to software to do it, it does not require human attention at that point.
Right. I think that I agree with you. I think the idea that the human could sort of say, okay, for the next day, this next day or next month, these are the rules of the game I want you to follow, and then let the software handle it from there, rather than expecting the human to do moment to moment. I agree completely with that.
Okay, David Inoue from the Bio Directorate at NSF. And following up on the first comment that we heard about your talk, there was an interesting article in the New York Times over the weekend about some counties in Northern California that have now put a moratorium on putting out smart meters because of so many of their citizens are concerned about privacy considerations. And so I think it really does point out the need to involve social scientists in these kinds of issues.
Yeah, I agree totally. Okay, thank you. Right. So this was obviously done by some scheduling algorithm that, given I'm here, so it's a great pleasure to introduce Mike Meyer. We're colleagues at Georgia Tech, and Mike is the Dickerson Chair in Civil and Environmental Engineering and the director of the Georgia Transportation Institute. So we're going to switch from the home to the car and the subway and the other kinds of vehicles. He's the former director of Transportation and Planning and Development for the state of Massachusetts. So he's been there in the real world and seen how things really happen. He has a textbook, Urban Transportation Planning, that is well regarded and is a recipient of numerous awards that I won't attempt to summarize. But I think it's interesting to switch from the house to the road. Mike?